All right, so today we have Omar Maher. He is Director of Product Marketing at Parallel Domain, and their tagline is Accelerating Perception with Synthetic Data. So Omar, welcome to the Data Exchange podcast.
Pleasure to be with you, Ben. Thank you for hosting me.
All right, so for our listeners, let's set a couple of baselines. First of all, synthetic data obviously applies to any data type, but for the purposes of our discussion, we will focus mainly on visual data. And I know that people have been trying to use synthetic data now for even structured data. And I don't know if you have any opinions on those topics, but let's assume for this conversation that is focused on visual data, and we'll also assume that listeners are familiar at a high level of what we mean by synthetic data, and some listeners who may not will definitely be familiar with things like DALL-E, Midjourney, or Stable Diffusion, so they know how to generate synthetic images at this point. So with that out of the way, so synthetic visual data, I guess let's motivate it by get people excited right away. Omar, what are some of who are the main users of synthetic visual data? I guess we can break it down by industry, or if you want, even use cases.
Yeah. Totally. Any machine learning team who are building perception-related tasks. So you said visual, which is very accurate. I mean, the bigger umbrella is perception, because sometimes you need radar data. And this team are hitting a wall in getting good performance on some of their models. I would say they definitely need synthetic data, period, right? So this applies to like retail, detecting products on the shelf, to self-driving cars, detecting pedestrians, to, geospatial agencies, detecting like building footprints. I've worked in projects across the board, and I've seen this problem, which is like hitting the wall on performance. And that's the point where I think synthetic data would be required.
So what's the level of sophistication that you need before you hit the wall? So how much computer vision are people doing before they start considering using synthetic data?
I mean, you try to you play all the tricks, right? Like you try to do your best getting good labeled data. Sometimes you don't have the labels. You start outsourcing this or doing it in-house with all the imperfections that comes with that. You try to apply different modeling techniques, ranging from simple, convolution neural networks to more sophisticated architectures. You try to optimize hyperparameters, and the list goes on. Thing is, sometimes this works, right? And you get good performance, and sometimes it simply doesn't, for different reasons that I can expand on, right? And I have witnessed that for years and years in my career. Like I used to be director of AI in multiple companies, and half of my work almost was computer vision related. And I can safely say that at least half of these projects did not continue because we either didn't have good data or not enough labels, or we were hitting that wall on performance.
So for people who don't follow the space closely, Omar, so compared to a year ago to today, what has changed in terms of capabilities and tools? Is it the fact that the underlying computer vision models have gotten better, so therefore the synthetic data generators have gotten better? So give us kind of a quick one-year summary of what's happened in the last year in this space of synthetic data.
Absolutely. I think if I want to summarize this with one word, I would say maturity and adoption, right? Synthetic data has been a hot topic since, a couple of years, 3 years, 4 years, whatever. What we have seen in the market that there has been more adoption of more companies in different domains using synthetic data to move the needle on their model performance, right? So it's no more R&D, it's used in production in different sectors. So that's one thing, like the adoption is definitely increasing. The second thing, I think it's definitely impacted by the wave of Gen AI happening, these days. Obviously, everyone is following up with ChatGPT, GPT-4, etc., which as you have seen, is coming to like computer vision with DALL-E and Stable Diffusion and all this.
But let me stop you there. So does that mean that because people now have hands-on experience with some of these tools, they see how good and realistic they can be. Has that translated to synthetic data generators? So the synthetic data generators have made a leap over the last year as well?
That's a great question. I think it's starting to happen. I'm not seeing it happening yet. And the intersection is mainly how can we leverage the progress in Gen AI stuff like Stable Diffusion, etc., to boost synthetic data generation. We are doing this in parallel domain. I'm happy to expand on that. But here's a very quick, important distinction that we have to make. There is a big difference between generating good images and trying to use this as a data source to train machine learning model. Huge difference between both, right? So we can use Stable Diffusion, other engines, etc., generate beautiful images, use for marketing, etc. But the moment you start training a self-driving car, for example, to increase its accuracy detecting, an edge case like vulnerable road users, that's a whole different story because you need labels, which not necessarily come with the Gen AI stuff. You need deep control over how you're gonna architect this specific edge case, etc. So the simple answer is yes, it's definitely impacting synthetic data generation, specifically in scaling content generation, which I can expand on. But I'm not saying like 100% overlap yet. There is still a lot of R&D to see how to leverage the Gen AI progress to improve synthetic data that can impact machine learning performance.
So actually, so for our listeners who don't actually deal with computer vision data on a day-to-day basis, so what are some of the key requirements for a synthetic data generation tool in computer vision? So in other words, is it like can you do prompt-based synthetic data generation? In other words, give me a bunch of stop signs where the stop sign is on a gate opening. Give me a variety. Some of them are, occluded. Some of them are crisp, and so on and so forth. And then do there have to be bounding boxes and so on and so forth? So what are some of the requirements that your users and customers want out of a synthetic data generation platform?
This is a great question. I want to answer this question, but I just want to have one step back to quickly highlight why do they need synthetic data in the first place, right? The need and urge for our customers that we've seen in the market, for example, to use synthetic data is, again, they want to increase their model performance and specifically on some edge cases. That's mostly the use case, right? So let's take an example. We are working with a lot of autonomous driving companies. They have great computer vision models detecting most of the cases, but then some of their models are not performing nicely detecting emergency vehicles at night or during adverse weather conditions, for example. And the reason is simple, right? They don't have enough labeled data for that specific edge case. And there are a lot of other edge cases, right? Pedestrians jaywalking, road debris coming up, animal crossing the road. We can count a lot of those. When they try to get this data in real life and try to go out, collect it and label it, etc., there are a lot of problems with that. One, it takes a lot of time. Two, it takes significant cost. Three, the labels they do are generally error prone. You can think of some labels could be super simple, like bounding boxes. Other are more involved, like semantic segmentation, where you need to be super accurate with the boundaries. Some labels are even almost impossible to label manually, like optical flow. So due to all these challenges, it's costly, error prone, takes a lot of time, and it comes with a lot of imperfections. So the alternative here is, what if I can program my own data? And that's when they start leveraging synthetic data engines.
Now, what is the user interface for a synthetic data engine? Because for those of us who don't use them, right? So we think of, maybe I just prompt this thing.
Well, actually, prompt, I would say, is definitely where everyone wants to go eventually, right? Because the prompt wave is just fascinating. I love it, honestly. I use GPT for a lot of things in work. And we're doing internal experiments in that capacity, right? And other companies are doing it. I don't think we're there yet. I think I might have seen a company or two who are doing semi-prompt, to generate.
So right now, I come to you, I specify what I want. I give you an example. Is that kind of...
That's one way, and there is another way, which is using our API. We have new capabilities where you can just program what you want. Hey, get me a night scene at this location in San Francisco at some road debris, at some parking, like some pedestrians here, some cars here, boom, you have something, you send this to us,
But
and
that's text in, right?
that's
So that's text in basically. So it's basically prompting via API.
actually it's Python in, so it's still text, right?
Okay. Yeah.
We would love at some point to reach like natural language, but yeah, you're right. So they write Python code using our API to generate this, and we work closely with a lot of our customers to ship them like big data sets with a lot of labels and a lot of variations, etc. So back to your question, which is a great question, by the way, which is like, what are customers looking at when they are generating data? I can immediately think of like, 3 or 4 major things. One, realism. The more the data is realistic, like it's closely matching the real life data that you're collecting, the better, right? Because imagine this, let's say there is company X, they have already collected a lot of real world data with some sensor, like a certain camera or a LiDAR sensor, and they have been training their models, but their models aren't performing nicely. When they're trying to get a reinforcement, some sort of reinforcement from synthetic data, this data needs to be as similar as possible visually to the real data, right? Because they're either going to join training or pre-train and fine-tune, etc. So realism is one thing. Diversity is another thing. So as you know, the more examples you have to teach machine learning models, the better. There are a lot of things that we do, for example, to increase the diversity. So for example, let's say you are trying to optimize for a certain edge case, like, jaywalking, for example, pedestrians, or partial occlusions, like a kid partially occluded by bus. Ideally, you want to have like tens of thousands of examples during different weather conditions, like night, daytime, dusk, etc. Different weather conditions, like, rain and fog.
And what's the QA process? Is it just visual inspection?
Yes, that's one part. So we have teams, for example, who inspect the data to make sure it's great. And then we have some other.
So the workflow is I send you a request via an API, some black box generates the synthetic data, and then there's kind of human in the loop to look at a sample before I download it.
Exactly. And we are moving more towards like less dependency on the human in the loop. So we're creating more tools, for example, so that customers can inspect themselves and correct things as they move forward. By the way, this kind of pattern of customers defining what they need, us generating, deliver, is like one major pattern. There is another main use case, not just for us, but in the market in general, using synthetic data for testing machine learning models. It's very important. So it's not just for training, but for testing as well.
What about video?
Video.
Synthetic video, is that a thing?
It's a thing. We don't do it. But here's the thing. Like, I think the need for video usually in most use cases boils down to like individual image frames, right? Because that's what you usually use to train a computer vision model.
Like if you imagine a surveillance camera and then you need to identify a specific event, it's probably at the frame level, right?
Exactly. Like if you're doing like object detection, tracking, etc., you just need the temporal sequence of the frames. So usually most of the machine learning teams that we work with, they just need the images, not necessarily like a video file, even if they're eventually going to deal with like a streaming, video or a streaming sequence of data. And we provide both. We provide scenes where you can see temporally, like how the data, like how the agents move and behave in this data, temporally, I mean, and then, the specific images that you use to train your models.
So what is the overlap, intersection, or relationship between the models that you folks use to generate synthetic data to the models that the Gen AI folks use, like DALI and Stable Diffusion and things like that? Are these two overlapping communities that kind of basically the same sort of people who work in these problems, or completely different?
When we are exhibiting in major conferences like CVPR, this is usually like the #1 question that we get, right? So people would walk across our booth, they see beautiful scenes and images, and they ask us, hey, is this generated through like GANs or, Stable Diffusion or something like that? The answer is yes and no. So here's the thing. When we are generating synthetic data, so that if we want to have like high realism, high diversity, etc., it takes more than Gen AI, right? That's what we have discovered. You need to combine the strength of both worlds. So for example, like procedural generation, like GIS maps, simulation engines that can accurately simulate your sensor and, the world, different agents interacting with each other. And at the same time, leverage Gen AI to scale content generation. So let me give an example for both. Let's say you're trying to get a data set to enhance your models on some edge cases, and you're looking for certain geography. Let's say Japan, for example, right? So you'd want to get a data set of like, let's say, hundreds of thousands of images showcasing specific edge cases in Japan during day and night, different times of the day with various weather conditions. And you have some constraints on how you want the data. For example, you need more pedestrians, you need more bicyclists, you need more animals, et cetera, et cetera. In order to come up with a realistic data set, you need not only to have like nice visuals, but to simulate the behavior of those agents accurately, right? Like how the pedestrians are going to interact in this data set, and how animals are going to interact, and how vehicles are going to interact. So you need a simulation engine for that, right? So this is a piece in our data generation pipeline. Two, you need accurate labels. So in many cases, we ship data to our customers with like 10 plus types of labels: bounding boxes, semantic segmentation, instance segmentation, depth, etc. So like Gen AI not necessarily is going to help you with that, right? It can generate images, but not necessarily like accurate labels. There are components for that.
And also, I think probably scale too, because the Gen AI things are so computationally intensive.
Yeah.
If you need thousands and thousands of examples, I don't know.
Exactly, totally. I mean, sometimes we generate like massive data sets and we need to do this in parallel. So we need infrastructure to do that. So I guess what I'm trying to say is that there is a sequence of components in the data generation pipeline, most of which today, at least in our case, are not using Gen AI, but using location, like maps, simulation, rendering, procedure generation, but at the same time, leveraging a Gen AI piece to scale content generation. Let's take an example. Let's say you need 2,000 different examples of trains, for example, right? Like you need different examples for trains because that's what you're trying to optimize for. And you need a variety, high variety between like European trains, US trains, different colors, different everything. If we want to create this manually through procedural generation, it can take forever, but we can combine between procedural generation and Gen AI and prompt the stable diffusion model, for example, to generate a wide variety of those trains so that you end up with like 2,000, 3,000 examples, which is, by the way, something real that we're doing right now as we speak, right? So I think in summary, you combine both different capabilities along with Gen AI to generate the best data sets. Does that make sense?
Yeah. In fact, as you were talking, I remembered having a conversation with someone in this space about a year ago, and he said, believe it or not, we actually hire a lot of people from kind of the Pixar's and special effects community.
Yep.
And as you were explaining, it makes sense, right? Because basically, certain amount of skill set that you need to generate some of these really realistic images, right?
Totally. I mean, almost half of our engineering team are like have been doing a lot of amazing work with like Pixar's of the world and gaming companies and stuff like that, because you absolutely need that for high realism and agent modeling.
So the concept of digital twin, does that play into this whole discussion that we're having in terms of simulations and things like that? And I have a pet peeve with digital twins, which is basically, if I can create such a realistic digital twin, then I basically, I basically created a replica of the world, right? So it seems an impossible task, right?
And that's why we think of it more as a digital cousin versus a twin. Here's the thing.
Yeah.
If you want to improve your models on detecting like a moose, crossing the road, or partially occluded pedestrians, do you need an exact replica of the data that you have, or need a complementary data set? You need the latter, most probably, right? So yes, you need something similar to your data set in terms of like location, weather, look and feel, sensor configuration, but you need an additional piece that you don't have today. That's why it's more of a cousin. So we provide you, for example, with like 10,000 examples in this data set for partially occluded pedestrians that you don't have in your real data set.
By the way,
Right.
Omar, map the output of a digital twin engine. Map that in the context of a deep fake. Is it that realistic?
It's a good question.
Or you're not going for exact realism. You're kind of trying to get edge cases, certain scenarios, but you don't have to look like this is real. You know what I mean?
I think we're trying to match reality, but we're not trying to be an exact replica, because otherwise it's gonna be just similar to real data.
So if I look at the output, can I tell it's there's something off here? Like this person's arm is too long, or you know what I mean? So I can tell that it's synthetic.
In many cases, you're not going to be able to tell. And we can play that game, by the way. Like maybe after the show, I can show you. Actually, in fact, we posted that quiz by the sometime on our LinkedIn page. Our like synthetic data engines, including ours, can generate like super high realistic data. But the thing that we're trying to deviate a little away from real world is, let's say, with the agent distribution. For example, having a super highly dense bicycles, for example, in this data set, like tens of thousands, totally unrealistic, but for a specific objective, because we want the models of detecting bicycles to improve. And that's why we increase that number. You see where I'm going? So in the terms of look and feel, we try as much as possible to have people not able to differentiate, but in terms of content diversity and redundancy and frequency, we try not to match the real world specifically for the edge case, because that's what we're trying to optimize for. And that's why it's more of a digital cousin versus a twin.
So we talked about lack of data, including edge cases and anomalies. We talked about cost, right? But another benefit, of course, is privacy, right?
Totally.
And talk to us a little bit. So in the use cases that you have worked on, does that really come up? I mean, because in the kind of autonomous car world, does that come up, or where does privacy come up?
It comes up all the time, right? Like imagine if you're trying to collect millions of samples, images in the real world, how many pedestrians and actual faces are you gonna have in this data set? And imagine the kind of effort that you need to put in to eradicate these faces to avoid violating any privacy concerns. You don't have that concern with synthetic data, right? Because everyone is just, virtual. It's not real. So that's a key thing, right? So I think privacy is a major concern when collecting real world data.
So wait a minute. So some listeners will say, you say that, but we've been reading headlines of how these Gen AI image generation tools have been found to violate IP. And IP means basically they based it on some real image, right? So
that's a good point, actually, right? And this is something we keep thinking about. The good thing is most of the data that we generate today is like the faces, for example. If we take that example, we don't do Gen AI in general for this today, but we generate this procedurally. So we have a lot of pedestrian models that we articulate and change the configurations to end up with a high amount of number. We are experimenting with Gen AI to generate faces. I think what you're bringing up here is an important aspect that we need to think about, right? The good thing is that none of the generated images would generally match an existing real pedestrian. So that is the part that our customers generally like from a privacy perspective, right? They don't run into these issues that they need to go and manually remove any privacy related. And faces is just one example. I mean, car plate, signs, for example, for cars is the same thing. Any kind of numbers or data that can point to specific individuals, you don't have that problem with synthetic data.
Earlier on you mentioned LiDAR, which is basically structured or semi-structured data. So how good are the synthetic data generators for generating that kind of data?
I think they are generally good. I mean, if I'm talking about parallel domain in specific, we provide highly accurate LiDAR data that is trying to do different things. First, like we match the sensors that customers use on so many aspects, like the intensity, the different ways they're collecting the data, reflection, etc. we take weather conditions into consideration. So we can simulate, for example, wetness and the impact it can have, and fog, for example, on LiDAR and how it would look like. And
So by the way, so let's say I introduce a new sensor tomorrow, right? So LiDAR 2.0. How long before you guys can start generating realistic? What do you need in order to generate realistic data from a sensor you've never seen before?
I think the more it is to other LiDAR sensors that we have simulated, the faster we can do it, right? And the more it's not, the longer this time could be, right? The good thing is that with most of the requests that we got so far, this was not so long. So we're talking a period of like, let's say 2 weeks up to a month, for example, to customize this configuration. And there are so many like configurations that are available out of the box too, right? Yeah.
So at this point, Omar, at this point in the evolution of synthetic data, do you still need to convince people that the synthetic data is useful, or are we past that stage where people need to be educated about the benefits, pros and cons?
It's a very good question. I think at this point, what I'm seeing is top tier organizations, like, those, like, let's say top N organizations, leaders of self-driving cars, for example, we find that they are using synthetic data, whether they build it in-house or outsource it. It's more about the other tiers, like.
Well, you mentioned, for example, retailers.
Exactly. Yeah. I think there is some level of good adoption from the top tier in most of the industries. So top retail companies, top AV companies, top drone companies, they're using synthetic data. But then the other tiers are still knowing about it and experimenting with it, right? So I think it's that phase in the market where we need to cross the chasm between, like, the early adopters moving towards the mainstream. And I think this would be facilitated by more self-serve tools and APIs, which we are seeing in the market from different players today. And that's what I'm definitely like starting to see. It's crossing that chasm from like early adopters to more like mainstream. And I think my personal expectation is that within the next 2 to 4 years, we're going to see like a major, transition to like more mainstream players.
So are you folks able to also generate the synthetic geolocation?
Geolocation. This is definitely a core part of our data. Like, if you mean by geolocation, produce data for like Japan, San Francisco, different cities, etc., then yes, we support that. Or you meant like lat long data, which
or no. Let's simulate I'm driving from where you are on the 405 to San Diego, and
Yep.
then in each each stage of that journey, you're able to kind of generate synthetic data for different conditions, different traffic conditions, weather conditions, and so on.
Exactly. That's actually right. Like, we support a lot of cities, a lot of locations in the US, for example, and Asia and, Europe, etc. We have availability for so many maps. Like a lot of our customers, for example, are in the Bay Area or like, San Francisco in general. So we have that. Other customers are in Japan. So we have maps for Japan. And as you mentioned, you can easily configure like, how I need this and that, like weather conditions, daytime, distribution of agents like pedestrians, vehicles, bicyclists, animals, whatever availability or distribution of edge cases. Like, we have like 20 different types of edge cases, so yes, you can easily configure this and we can generate this data for you.
So we've talked a lot about the positive things. So what are some key challenges that remain? So over the next year, what will be the synthetic data generation community focus on trying to overcome?
I love that question. And by the way, I'm not really trying to market for whatever. We have a dedicated workshop in CVPR, the Computer Vision Conference of the Year, just about that topic. So what's next in synthetic data? We have speakers from research, academia. And to provide you my personal insight, I think there are a couple of topics here. One is how to bridge the domain gap. So usually when you use synthetic data, there is some gap between, like a visual gap, for example, or an agent distribution gap between this data and the real data, right? And there are some techniques and methodologies to bridge that gap, like, style transfer and, doing different visual post-processing, etc. So that's one thing. There is active research happening in this space, to reduce that gap as much as possible. 2, how to best leverage generative AI to streamline synthetic data generation. I think today, I think we can 100x, for example, the data that's generated and the value from it, if we find that sweet spot where we can leverage things like stable diffusion, etc., to scale content generation, which we are actively doing inside Parallel Domain, by the way. So that's another thing.
So the challenge there is that those are black boxes that you don't control in the following sense, because your requirements are much more precise and specific, right? So give me an image of this in this particular location under this scenarios with these labels and so on and so forth, right? So
that's a great point, actually, because combining both control and Gen AI, in my opinion, is gonna help achieve best results. So let's take your scenario. Let's say I want to have, for example,
my favorite example here, Omar, is the stop sign that's on a gate.
Actually, it's funny because we recently did a sign detection experiment with a European customer. They have this mandate in Europe to be able to detect speed signs, etc. We have seen 15% mean average precision increase. So yeah, let's take road signs. So what if I can tell you that I can give you your exact city, different weather distributions, and various amount of types of signs, but I can provide you thousands and thousands of how visually these signs would look like, not just 10 or 20 or 100 examples.
But see, this is where I'm skeptical about the Gen AI at this point because of the latency.
The latency of generation, you mean?
Yeah. Because if that's just one scenario, and then I give you, let's say, 100 scenarios, and for each scenario I have so many kind of permutations.
Well, you can solve that trick by doing let's say you can generate the embodiment of the sign and just use stable diffusion, for example, to change how it looks. So in that case, you're not generating a whole scene. You're just you're trying to fill that part that was already produced by procedural generation, and you're asking.
But I guess my question to you is, what does that buy you that you can't do now? So in other words, obviously when you want to bring in another piece of technology, you always ask yourself, what advantages does this offer compared to the baseline of what we're doing today? So what do you think the advantages are of using even bringing in the Gen AI into this pipeline?
Scaling content generation. Let's say I would like to have 3,000, 10,000 types of debris on the road, not just 100. So we have, through procedural generation and graphics, let's say we have created 50 different types of debris that you can place on the road, right? Which is a major use case for self-driving. What if I would like tomorrow to have 3,000 different variations? One thing I can do is to leverage the data generation pipeline, the non-Gen AI pipeline, to have debris placements on the road and realistic cities and everything. And then I can ask Gen AI to fill in this box, for example, with thousands of variations of debris. I can prompt it, right? So what it buys me is time. Instead of spending 6 months on this project, I can do it in a week, for example, and have 3,000 types of debris.
I see. So okay, so go ahead. So what else is on the R&D radar?
So we mentioned reducing the domain gap, better connection points to Gen AI. This is definitely a thing. There's a lot of research happening in the nerves, and it's still around the same sphere of trying to generate highly realistic images, let's say from 2D images, right? Another research aspect is using real-world data to guide the synthetic data generation. So let's say, for example, you have collected a ton of data by driving around in San Francisco, and you'd like to use the same data collected to generate, similar data, exactly the look and feel, etc. But you'd like to place some additional edge cases, hey, I want the exact same data that I've collected for this street, for example, but insert 10 pedestrians jaywalking here, for example. Instead of generating the whole thing from synthetic data, there are some research techniques that would enable you to bring the very data that you have collected in real life and just insert pedestrians here. It's not super stable yet, and I'm not talking about ourselves, but generally the industry, but this is an active area of research too, right? The democratization of synthetic data tools. Today, it might be a little involved, especially for outdoor scenarios, right? So it's different when you want to generate like faces versus whole cities, right? And as I mentioned, you can use APIs to generate this today, but it's a little involved. But moving forward to make this easier and more self-serve and faster and stuff like that is something. NVIDIA is making good progress here. We are making good progress. Other companies are making good progress. So more democratization for these tools through APIs and potentially through prompt engineering, like natural language. Build me a city with these kind of things, and everything runs in the back end. So I think these are four major topics that I see happening. Right, bridging the domain gap, more connection points to Gen AI, more, the ability to bring in real data and use it to generate synthetic data or insert things in this real data. Maybe more natural language approaches to generate the data. I think these are like different things that I expect that we're going to see in the next, 2 to 4 years, for example.
So, on the question of democratizing, is there a movement towards computational democratization in the following sense? Can I do everything in a simple laptop?
Yes, because it's using the cloud, right?
No. But let's say I'm offline.
Mm-hmm.
So how much computational resources right now are required for doing a lot of these things? Still a lot, right?
It's a little significant, right? I mean, and it depends on the scenario. So for example, let me give you an actual example. If you want to generate, like, let's say 100 images just to test drive and see how this would look like, it's not computational intensive. You can do this on your laptop, for example, right? The thing is, it's just going to need to call some APIs, right? So that's when you need the internet, but it's not computationally intensive. But if you want to generate a data set for a whole city, right, or a half city with a lot of weather variations, it's a little involved. Like you require, for example, to parallelize this on Amazon, you might need, like, let's say 5 to 10 instances, stuff like that, right? So I don't think it's gonna become computationally trivial anytime soon. And it's not crazy too, like you don't get $1 million bill or anything, right? But you just need to parallelize things and use multiple instances. That's the state of today. Maybe Gen AI is gonna change that, right?
What about so in closing, Omar? So one, I've been kind of dying to ask you this question, which is we talk a lot about we've talked about retail, autonomous vehicles, but obviously one domain that uses a lot of images is medicine, so medical imaging. So what is the usage of synthetic data in that domain? In other words, are you at the point where you can generate, computationally or useful MRI images so that to help train some of these ML models? Because any given year, maybe these MRI, there's only a few thousand MRIs for a specific part of the body, right? So what's the state of usage of synthetic data in the medical domain?
So we are not working in this domain yet, but and I'm not super familiar with who's doing what here. But my hypothesis or my guess is there's definitely companies doing this right now because it's a major field, right? And it needs a ton of labels. So I'm sure there are some companies / open source frameworks that can generate data that can, enhance MRI detection models. And by the way, a little related to that, have you seen the recent, release from Facebook Meta AI about segment everything? The segment everything.
Oh yeah.
I've seen someone on Twitter, I think, trying this to segment, I think, an MRI scan. And it worked really nice. And this is a foundational model, the segment everything, which again brings us to the point, which the progress happening in Gen AI, I think is definitely gonna impact the whole computer vision society. And that was some example that I saw on Twitter.
Because it's an interesting domain in the sense that at the end of the day, it's images, but there's so many different kind of vendors and manufacturers, right? So they generate their own images, and then they have readers. Obviously, you can export it to image files, but at the end of the day, it's an image file. So then at some point, someone might be able to generate realistic image files, but you need a lot of domain knowledge, right? Because basically, you have a sequence of MRIs and you have to generate it so that it's actually real, adheres to medical reality somehow.
Yeah.
Right? So,
Yeah, and that's why I think domain-specific tools are important. Like we focus big time, for example, on the driving industry, the autonomous drones industry, the outdoor robotics. Others focus on faces and humans. Other focuses on, you know, tabular data. I think this kind of focus on the data type / domains is important, at least initially, because you're right. You have to match reality, or like you have to be as realistic as possible. And this is a little hard to achieve without having this kind of domain knowledge.
And with that, thank you, Omar.
Thank you so much. Appreciate it. It was a pleasure, man.